Assalamu alaikum students. Today our topic is related to scattering of light. What you understand by scattering of light? When the sunlight enters the Earth's atmosphere, the atoms, the molecules of the different gases that's present in the atmosphere, I simply say the molecules of the air. Air consists of oxygen, nitrogen, or so many gases. They first absorb the light, and then these very atoms or the molecules of gas, they re-emit the light in all the directions. This re-emitting of light in all possible directions is known as scattering, Bikharjana. It is going to go in all the possible directions, and that thing is known as scattering of light. And those very particles, those very atoms or molecules which scatter light, those are called as scatters. What are scatters? Scatters, you can say these are the scatterers. Scatterers are the atoms or molecules which simply scatter the light. Those are called as the scatterers. And this phenomena of re-emitting, first absorbing then re-emitting the light in all possible directions is known as simply scattering of light. Now, according to Rayleigh, the intensity of scattering is inversely proportional to the lambda raised power 4, that is the fourth power of wavelength. That means, as we are aware, we are having seven colors: vibgware, violet, indigo, blue, green, yellow, orange, and red. Among all those very colors, the red is having the most largest wavelength, and violet is having the smallest wavelength. So I will say, if lambda is very large, lambda is large for red color. Once it is very large, then its intensity will be very small. So I will say red color. Red color will will scatter less as compared to violet. So violet is going to go scatter more and more. Simply, it was the Rayleigh's law, Rayleigh, who postulated law, who said that intensity of scattering will be inversely proportional to the wavelength. That is, the color which is having more and more wavelength, the intensity of scattering will be least. That is why the red color will scatter less as compared to the violet color, because the more and more wavelength we are having for the red color, and we are having less and less wavelength for the violet color. Now you might have seen some phenomena. Sometimes we will say, if why the sky is blue, or how would the sky appear in daytime if there is no atmosphere. If there is no atmosphere, if there is no atmosphere, then sky will appear black in daytime. Why? The reason behind it is that there will not be any kind of scattering. Once there is no atmosphere, if there is light, when there is no atmosphere, there will not be scattering. Once there is no scattering of the light, and the sky will appear black. For the astronauts which go in the outer space, the sky appears black because there is no atmosphere. Although light is traveling, but there is no atmosphere. Although light travels through that free vacuum and reaches to we people. So when Earth has no atmosphere, sunlight will be visible only if we look directly at the sun. Otherwise, you were not going to see what? There will not be any scattering as there is no atmosphere. So if there is no atmosphere, the sky will appear black in daytime. Why the sky is blue? Why? Sky is blue, as now you have read, sky should have been this very violet, because violet color is the color which is going to scatter most as compared to the blue. But as our retina is very much sensitive, retina, the retina of our eye, that is very much sensitive as compared to, is very sensitive as compared to what is very sensitive to blue color, to blue as compared to rest of the colors, or you will see the violet, because mm, as from this very formula, the violet color is having least wavelength, so its intensity of scattering will be more and more. But what the sky, that is blue, that is this very the third number which we are having, the blue color. Why it is blue? Because our retina, our eye, you will say simply, the eye is very much sensitive to blue color. That is why the sky appears to be what? Blue. Now you will see once again there's another phenomenon of this, why clouds are white. The clouds are white because clouds scatter. Clouds clouds are white because they scatter all the wavelengths. They scatter all the wavelengths falling on them. So if white light falls on them, on the clouds, so they scatter all equally, and as a result the reflected ray, the scattered light is also white. That's why clouds are white. And sometimes you see the danger signals are red. Once you are going to see tower, the light at the top of the tower is the red color. Why that is red color? Because the red is having more and more wavelength, so it is going to scatter less, so you can see it from a very far off place. You might have seen in the medical buildings, or you will say the hospital buildings, there you are having written like this edge, and that very edge is written in what? That is written in the red color. Why that is written in the red color? Because one is during there will be a warship, there will be a war between two countries, or there will be the emergency, so this will be recognized from a far off place, because it is not going to scatter. It is going to be recognized if there is bombing, so they will not bomb those very buildings where there is an edge, taking into consideration that these are the places where the medical facilities are provided. Yeah, simply you can see these are the hospitals. That is why danger signals are red, or even if you are going to see the H written on the hospital building, that is in the red color, because red you are going to see from far off place, and it is not going to scatter more and more. That's why you are going to see it from a far off place, and thus the building is saved. Simply, uh, these very danger signals are red in color because the red color is least scattered, and you are going to see it from a far off place. This is all for today's lecture. Tomorrow will be with another lecture. Till then, Allah Hafiz.